Now in this video, we will talk about the coenzyme of niacin, which is apparently the most important, as well as functions of niacin. All right. So it looks quite complicated, but it is quite simple and very, very easy. All right. So let us start going ahead. First one, let us concentrate here. This one is our niacinamide. Remember, we showed niacinamide. And there is a plus charge here indicating that it can accept electrons. Okay. Now, this is bound to a ribose group, which is attached to a phosphate group, which is further attached to another phosphate group of a ribose phosphate, ultimately attached to adenine. So, if I remove all that confusion, then it is niacinamide, ribose, diphosphate, ribose, and adenine. So, do you have to remember this complex structure of nicotinamide adenine dinucleotide? No, you need not. If you want to write the structure also, the shorthand form of writing the structure is more than enough. All right. So, what we would like to hear in this, I would like to draw your attention to two places because following video will talk about the redox function of NAD. Okay, so here in niacinamide, you have an amide, and at N you have plus, indicating that it can accept electrons. Okay, and this whole coenzyme is nicotinamide adenine dinucleotide. Niacin has got two coenzymes. One is nicotinamide adenine dinucleotide. Second is nicotinamide adenine dinucleotide phosphate. So obviously you need another phosphate group to make that particular another coenzyme, right? So how do we make that coenzyme? Let me draw your attention to this OH group, which has asterisks on its top. If this is, if it has a phosphate group over here, esterified with a phosphate group over here, then whole structure will become nicotinamide adenine dinucleotide phosphate. Let me just show it for you. Simple. So you take out that OH group, and if it is esterified with the phosphate group, this will become nicotinamide adenine dinucleotide phosphate, or NADP+. Secondly, when you write the oxidized form of niacin coenzyme, that is NAD or NADP, we always have to mention this plus sign. Why? Because it indicates the sign on the nitrogen. All right. We will talk about its redox potential in the subsequent video that we will make. Let us now talk about the main functions of our coenzyme. We will actually talk the functions of coenzyme of NAD and NADP+. Okay, NADP+ further will be NADP generating and NADP utilizing. In brief, you remember all the down metabolisms usually utilize NAD or NADH, NAD+ or NADH. All the reductive biosynthesis, all biosynthetic enzyme, reductive anabolic pathways, they will use NADP+ or NADPH. Right? As you go through all the metabolisms, it will get much more clearer. So, which are the NAD-dependent enzymes? Lactate dehydrogenase, glyceraldehyde 3-phosphate dehydrogenase. Most of the dehydrogenases will have NAD. Okay, pyruvate, alpha-ketoglutarate dehydrogenase, beta-hydroxycyl-CoA dehydrogenase, glutamate dehydrogenase. Now, most commonly students will ask how many functions or how many examples we have to remember. Now, that actually depends on the weightage of the mark. Okay. And now you might find it quite difficult to remember all these, mug up these enzymes. But once you are through with whole of the metabolism at the end of the year, will actually, you yourself will come up with more examples rather than one or two restricted examples. Okay. Don't worry about it. If you forget everything, at least you can mention dehydrogenase enzymes. It will be the simplest one. preferably you have to mention which are the enzymes like lactate dehydrogenase, pyruvate dehydrogenase. Start with carbohydrate metabolism. See how many reductive metabolisms are there, and then go with lipid, go with amino acid. That way you can categorize to memorize and remember things much better. All right. I said no, NADPH has a special mention. It has two things to be spoken about. One, NADPH generating pathways. So it is not a function per se, but yes, we have to talk about it. And then NADPH utilizing pathways. NADPH generating, you have glucose 6-phosphate dehydrogenase pathway, HMP shunt pathway. There are two reactions in that, which is one is glucose 6-phosphate dehydrogenase and second one is 6-phosphogluconate dehydrogenase. At both these reactions, NADPH is generated. Again, as I said, when you will be thorough with HMP shunt pathway, you need not mug up these enzymes. You will know about these enzymes and you can very well mention it. This is a very important question. Mention about the NADPH generating enzymes, or what are the sources of NADPH. This is a very frequently asked questions for 2 or 3 marks. So you should know about this one. Okay. Second, third one, and the rich source of major source of NADPH comes from HMP shunt pathway. All right. Followed by cytosolic isocitrate dehydrogenase. Third and fourth one is malic enzyme, which converts malate to pyruvate. Okay, malate dehydrogenase enzyme. So these are NADPH generating pathways. Then you have NADPH utilizing reactions like beta ketoacyl dehydrogenase, alpha beta unsaturated acyl ACP to ACP conversion, and HMG-CoA reductase enzyme, methemoglobin to hemoglobin conversion, folate reductase, phenylalanine hydroxylase. So all these are NADPH utilizing reactions. In the next video, we'll talk about deficiency disorder of niacin, that is DEGRA, which is very, very important. Thank you.